Hey people, so I'm gonna be writing an evaluator today for my Lambda calculus Repl. So this is the project I've been working on for for quite some time. Not that quite, but recently I've started it. So far, like you can type in variables like it maintains history and so on and so forth. Like I built a lecture and parser for it as an exit function, so that you can exit out of the REPL, so on. So I'm gonna build an evaluator now. So I thought, okay, why not record a video of it, right? Uh, yeah. So that is what this video is about. So basically, I'm gonna build an evaluator for Lambda calculus. So far, just to give you the history of it, I've built uh, Alexa and parser and like the three most important nodes for Lambda calculus, right? This is the base node and some basic like uh, programming language stuff, right? So yeah, so let's start. So so variable node, there is nothing to reduce in variable node, so we return it as it is. In Lambda abstraction node, we should be reducing the body of it. So how can I implement this? So if we take this expression, right, it should be like this. So and we return a new abstraction node with the same param and the reduced body. Application is we should first reduce it, this to reduce and check fetch and abstract. If YAM is not an abstraction, then reduce. So this is what we should be doing. Also, like we have to do some substitution stuff as well. I think this sounds good for now. So we'll do the so once we reduce, we'll check if it's the reduced thing. Let's say so here m is equal to and m is equal to this one. So if new left selection mode, we should substitute this thing, right? Whatever is on the right, we should be substituting. Basically, we have to substitute this whole thing to this particular x, right? So we should be saying or else what we can do is, like, if it's not an abstraction, we'll reduce the right side of it. And finally we'll be returning application mode of left right. So here is the main important part. Self nodes substitute. I'll talk about what substitute is, but I'll write this equation of it for now. We have to substitute param, basically new left dot param, new left dot body, and then we'll have to do ast dot right. So once we get this thing, we'll be having substitute result, and then what happened, this pen thing, 1 second, let me reopen my thing. See if it's okay. It's cool. We'll return self dot getter reduce, right? So we'll return this thing. I think this should work. So we'll reduce the left side of the expression first, and we'll check if it's a lambda abstraction. If it is a lambda abstraction, we'll substitute the argument with the parameter. We'll get the result back, and once we get the result back, we again reduce it further, and then we'll return the result so that the evaluation will be completed. If it's not a lambda abstraction node, we'll reduce the right side of it, and then we'll return new application node. Yep. This sounds good, I think. We'll now implement substitute. Param, which is an expression, which should be an expression. Body is an expression. And then this should be an argument, which is also an expression, right? The same thing we have to do. We can use the new match thing, but this should work for now. Maybe while refactoring I can change it. Okay, now, so what is substitute, right? So basically, let's say I have an application like this. Okay, substituting this x and this x with a. So while once the evaluation is complete, we should be getting this a as our result, right? Similarly, so this is the crux of it. Once I've implemented it, maybe I'll go over some test cases and see whether it's working fine or not. I actually have some test cases. I'm not sure where it is. It's fine. So variable node, right? So basically, you have to check if the param is equal to body dot value, and if that is the case, then we should return the argument. If that is not the case, we should return the body as it is. So basically, what I'm doing is, imagine this is the expression we are trying to evaluate, right? So this is the one. Here the parameter is x and the body is x. So the Python equivalent of this function would be like this: def fn x return x, right? So if we call f of 1, we should be getting 1 as a result, right? So this is what I'm doing here. So if our body, right, if this whole thing is of so not the whole thing, if this x, the which is right after this dot, right, if this thing is a variable node, if this is a type of variable node, we'll check if the parameter is nothing but this x, and body dot value is nothing but this x. If both are equal, then we should be returning this a, because think about it, if we apply a to this function, first a will be coming here x, the value of x would be x, and here is also the variable is bounded, right? So the value of this would be a as well. So we return the argument. If let's say if it's y, in this case this condition would fail, we'll return the body itself, which is nothing but y over here, right? So that is basically for variable node. So what is up with this lambda abstraction, right? If the body is of type lambda abstraction, so I'll put it over here. So fn x dot fn dot y, right? So what if this is the case? Right, first, this is the body, this whole thing is the body, right? And this is the outermost thing, this is the parameter. First a will be applied to x, right? And it will see if the body contains anything. If it's a lambda abstraction node, if it's a variable, it will be direct, it will be straightforward, right? It will be one variable, it will be easier for us. But that is not the case for lambda abstraction node. We have to first check whether this body, right, if the parameter of this body is equal to this. if it is equal, means both these parameters are bound, but there is a priority here. If both the x's here, right, like if for some reason there is x's here, if this is the example, then we shouldn't be replacing anything, we should be applying anything, because this thing is bound to whatever variable is present right after this dot, basically local variables, right? So that should be our top priority, not this one. So in this, if this is the case, we shouldn't be replacing anything, we should be returning the body as it is. But this is not the case, right? So that is what we have to think about. So if param is not equal to body dot param, basically x is not equal to y. So in that case, what should we do? In that case, we should do something, but let's return, like if we know, like if both are the same, right, we shouldn't be doing anything, we should return the body as it is. Or like if both are not equal, then we should try to reduce it, right? We should try to substitute this thing and see what happens. So self not substitute. Oh, I forgot. Substitute body dot param and body dot body. Once we get the result, right, what should I name this thing? For now, I'll name this R. Then we can return lambda abstraction node of the original param, not the original param, body. So I think it should be param. Then this result. Let's see. I think it should be. Oh, sorry. It should be opposite. We shouldn't be doing this thing. We should be doing param. And here it should be body. Because like see, so this is the original parameter and this is the body inside the body and this is the argument. So this parameter refers to x over here, right? Okay, now the last part, application node. This is nothing but mn, where mn can be anything. Like m can be a variable, m can be a lambda abstraction, or m can be an application. So it's just because like most think of it as a like this is recursive function, but both of all the base cases are covered over here, like variable node and abstraction node, like both of these covered are base cases. So we can just do substitute param body dot left argument right and finally we'll return the application node new left new right. I think this should work. Let's see. Okay, fine. If I do fn x dot x and a, okay, yeah, it's applying. Like this is working fine, I guess. And if I do fn x dot x, see, yeah, it's working fine. So here, like I'm applying this function to this argument. So a will be passed to here and returning a will be returned as x. If we do something like y and then we return a, like we shouldn't be getting y, right? So it's why it's like, so it's working fine. I think I have few test cases somewhere. Yeah, we'll check this thing, right? Like if we execute this, like just now we saw it, right? Like if we execute this, we should be getting this as in return. Let's see. Yeah, this is working. Y, yeah, it's y. This is an application. Y is getting replaced for both x's. So what is the function yz, function y, and then z variable node. Fine, this is fine. Yeah, this is x zy, correct. This is also we have already executed. Is it? Yeah, it's working fine, I guess. Probably I can like remove all these if else's and like do match thing, right? If I were to do that, let's refactor, right? Let's refactor both these things. Not sure how much PhD. So I haven't used this match for some time, quite some time, so I'm not sure how smooth it will go. Next is Lambda abstraction node. We have param and body, right? So what we'll do is reduced body equals self dot weight difference of body, and finally we'll return Lambda abstraction node of param comma reduced, right? So third is Lambda application node left and right. Here we'll reduce the left first, self dot beta reduce of left, right? And we'll check here, like, we do have to check one thing, so this instance is fine, right? So here self dot substitute. I have to have finally one return. If that is not the case, then we'll reduce right self dot new. If none of the thing matches, we'll raise this thing. Okay, let's see if this works or not. Expected in 328. Oh, I have to do this thing as well. First, I'll remove this and see if it's working fine or not. Wait. Where is my test cases? Where are why it's fine? Fine. Oh. F1 Y is fine. Fine. Okay, this is working. This refactor is fine. Can go ahead and remove this. Same way I could refactor this as well. Okay, here if param is equal to value return the body as it is. If param cases this thing both the things now it's not so substitute original param, the body param, right, and then we'll return lambda abstraction mode of underscore param and else we'll return the body as it is. Abstraction let's see if that is working fine or not. Unknown not type Y. So this is something is wrong with here. Oh, sorry, I should be passing the body over here. Okay, fine. So F and Y is A fine. CY fine. Fine, everything is working so far. So I can remove this as well. Yeah, so far everything is working fine. Yeah, I think that's it. Beta reduction is done. Probably I'll implement alpha conversion next. Not sure whether that whether I'll be recording a video of it, but yeah. Yeah, that's it. Thank you.